All right, let's see. So now we're going to talk about another rec. Sorry, I was having an internet hiccup over here. All right, we'll talk about generics. And so the idea is that, remember, one of the things that we talked about before. So one thing we talked about before was that there's three different types of errors. There are runtime, compiler errors, runtime errors, and logical errors. And remember, one of the things I said is for each of them, they're encountered along the way, right? So compiler errors are found when we go to click compile. We try to convert our Java code or C code or whatever language we're writing in. When we try to take that code and convert it into machine code, into something the computer can use to run, and there's some type of error, there's a syntax problem. We've done something that the compiler does not understand and cannot take that code and make it into machine executable code. Okay, so then you have the runtime error that once the code is compiled, there's no syntax problem with it, but somewhere while running, something gets wrong. We try to divide by 0. We try to access an array out of bounds because that's something that a compiler doesn't necessarily know. If we access an array with an index I and we put the value in I that is outside the bounds of the array at runtime, the compiler can't know that in advance. Okay, there's a lot of work going into artificial intelligence. It's still not there, and Java definitely can't. Okay, Java compiler definitely cannot do that. All right, so the runtime error is the code compiles, it starts executing, it ends early, and then logical errors. The most annoying because code compiles, it runs, it gets to the end, it completes, everything's happy, and oh wait, there was an incorrect value. There was something output that was wrong. We got 2 + 2 = 5. We wrote the wrong thing to the wrong file name. There's all kinds of possible logical errors. Okay, these are the worst because most annoying because they're the hardest to find. Okay, so the part of what the benefit of generics is we're going to be able to take things that used to be runtime errors and now will become compiler errors. And you might think, wait, why is that beneficial? Why is that? Who cares where the error happens? Remember, one of the things that said is with each level, so compiler errors, we experience those first. Runtime errors, we experience those after we've compiled and we start executing the code. Logical errors, we experience only once the code is done and it's completed. Okay. So if we can find the error earlier in the process, that's good. That can be really good. It'll save us some time. All right. Another good thing about finding errors earlier, finding errors in the compile time, for example, is that we also can become more aware of where the error is. Remember, compiler errors, when we click compile and we get a compiler error, it points us directly to the line. It's like, this line was the problem. You don't have a semicolon. You're missing something. You don't have a close quote. Whatever. It's like, there's a problem on this line. Runtime errors, they tell us where the code stopped executing. That's not necessarily where the source of the error is, right? It ends on a division problem, but I don't understand why A divided by B didn't work. And then I've got to go search my code to see, was there somewhere that B was set to 0? Who knows, right? And then finally, logical errors are the hardest to find because we have no clue. We have no hint as to where it happened because the code ran to completion. It completely ran and everything was fine, and it came all the way to the end and no problems from a compiler or runtime perspective. So then we have to search through the entire code to try to figure out why did this logical error happen. So if we can push errors to the compile time as much as possible, that can be very helpful for us to find and fix any potential errors. Okay. All right. So let's imagine we had this array list. All right. So many of you used array lists for your assignment 2. Okay. Array lists are very good. They can be a very useful tool. They're like arrays, but dynamic. We can make them grow. All right. So here you have a list, an array list called list. We add something to it. We can add a string to it. Now, an array list on its own is just an array list of objects. So we can put any object into this. Okay. Now, if we were to, if we were to compile this using a higher form of a JDK, a Java Development Kit, than 1.6, this would result in a compiler warning, not a compiler error, but a compiler warning. And it would basically tell us, hey, you didn't tell me what type of array list this is. Okay. So now if we say, okay, I want this array list to be a string array list, I'm adding a string to it, no compiler warning. Okay. Now you might say, but wait a second. Here you said an array list was just objects, and strings are objects. So why is there a compiler warning? For one, this is not a compiler error. It will compile and it will run. It's just the warning is telling you you did something here that could cause problems. Okay. So it's just a warning, not an error. And the reason why is because I can put strings in here, but I can also put other objects as well. It doesn't have to be strings. And then it could result in kind of weird stuff if I try to do a sort, right? Try to do a sort on things that aren't the same, right? Strings and other objects mixed together. All right. Okay. All right. All right. Yeah. And again, the key benefit is being able to detect them at compile time over runtime. So here, let's say we had the comparable interface, where we take an object, we compare it to, we take an object past, we compare it to the current object that implements this interface. And if the current object is greater than this, we return a positive number. If it's less than this, we return a negative number. If they're effectively equal, we return 0. Okay. Prior to 1.5, JDK 1.5 and up, we add this generics part to it. So now we say it's going to be of type T. It's not just some generic, some object of any type of object type, but it needs to be of a specific type. And the reason why, again, this pushes to what is it? The runtime versus the compiler error is that in the old version, this would be allowed. Okay, this would be allowed by the compiler. Comparable C, new date, right? So we're creating a C comparable. That's a date. Okay, so date implements the comparable interface. Great, no problem. But C is a date object. So when we try to compare it to a string object, how do you compare a string and a date? This is going to end up in a runtime error. Because you cannot compare the two of them to each other. A date and a string. But now, this in the upper versions of JDK, because this is not a date, this is going to be a compiler error because I created a comparable object, right? And said it needs to be a date, so it's like it substituted for the T's here this date. So now it's an interface of date. It needs to take another date object. Okay. So then when we try to compare to, and then we pass it a type that is not the same as this, now we get a compiler error. Runtime error when we don't have the types, compiler error when we do. Okay. So these differences in the array list implementation. Now instead of adding any old generic, any object that we can, we're now specifically saying what types of objects we will take as part of the add method, what types of objects we should return, what types of objects we should set at a certain index. Okay. And again, this is probably for a lot of you like, what's the difference? I don't understand why there's a difference here. What's the difference between E and object and all this? It just has to do with we're setting what types of things the array list or other things that we can add generics to. You'll see hash maps. We'll talk about hash maps in future weeks. The comparable interface, all these types of different things that take this generic type. We can say, I want to specify what types of objects or what types of whatever it can take. All right. Okay, we'll look at this example if we have time of the generic stack. Question? Yeah, I mean, if you write object instead of E, you can add anything, but object does not implement the comparable interface, so that may be an issue. But that'd be a good one. That's a good question, and we can take a look at that when we do the examples. All right. All right, so here's some different methods. Notice they're the same basically, except here, right? We're specifically saying when I make this method, I want to be able to say what I pass to that method. So here we could have a bounded generic type, meaning we're saying that E, we can take any type of E to this equal area method, right? Where I'm passing it a rectangle, I'm passing it a circle. I don't have to pass it the same exact object types. So notice the rectangle is a rectangle object. The circle is a circle 9, whatever that is, a circle 9 object. And you're saying, but wait a second, a rectangle and a circle, they're both E, but they're not the same thing. So how is that a possibility? When I say here that E extends geometric object, what I'm saying is I can pass any geometric object to here and any geometric object to here. They do not have to be the same exact class type. Okay. Yeah, so like you said, Recep, like you asked a moment ago, if I leave it empty, it's basically the same thing as object. So it would work the same way. It would work very similarly. But I think, again, because the object class does not implement the comparable interface, I think it may still give you a compiler error in the new JDK. It's a good question. We're going to take a look at that one. Got to take a look at that. Okay. Okay. So here, right, we're going to take the comparable interface and then the old way of doing it, right, with no generics. Well, does the string implement the comparable interface? It sure does. Does an integer object implement the comparable interface? It does as well. And since they are both comparable, we could pass them here. Right? We could pass them here, but we would get a runtime error. But if we say, okay, I only want to be able to pass an E where it extends the comparable of that specific E type. So this one's a little bit tricky. Okay, this one's a little bit trickier. All right, so let me explain this one a little bit better, and hopefully it'll make some sense. Okay, so when I say that E extends comparable E, oh gosh, so many E's, right? What we're saying is whatever I pass for E into my method must extend the comparable, and it must be the same type. Okay. So if I pass string, so then what it says is string here, where string extends comparable string. So then the second one must also be something that extends comparable string. It doesn't have to be the string class itself. Okay. If you created another class that extends string and you were like, and you called it, you know, special string, right, or something like that, then that you could pass that in there as well. But here, because integer does not extend comparable string, I cannot pass it in as the second value. Okay. Let's see. So there's a couple other things that I wanted to go over. Oh, definitely. Let me go ahead and go here. Okay. Some restrictions on generics is, so you cannot create an instance of a generic type. So you can't create a new E, whatever. There's no E class like this where we can, no concrete E class. Okay. We also can't create an array of E objects. One more, exception classes cannot be generic, so we can't create a generic exception class. Be nice, but can't do it. So is there anything else here? Okay. We can talk about this generic matrix. Actually, I will probably not do the generic matrix here in class. I'll let you take a look at it as part of your outside of class work. Okay. All right. Let's look at some examples, and then we'll call it a day. Let's see. All right, so you have this max and max using. So I already did this one here, so I did this earlier. let's see, generic method. That's what I want to do. I want to do that one too. Okay. So here we have a generic method demo print, and I can print the array. Notice I don't have to have separate methods for printing an integer array or a string array. So I can pass two different types of arrays, an integer array and a string array, into the same method, assuming that they do the same thing, right? We're assuming that they do the same thing. Okay. What were you? You were asking about, which one were you asking about? Is it? Oh yeah, the equal area one, right? Yeah. Okay. So I can create a single print method that takes an array of whatever E is. And then when I go to call that method, I simply say I'm passing it an integer. Whatever E is, I'm passing it an integer array. Okay. So let's see what happens when we compile this and run it. And as you would expect, it just basically prints out the different values. Okay. So when I take this integer array and I put it into this method, it first says, okay, what type am I expecting, right? And what type is it going to be? Okay. Now, could I have done this with, let's see, could I have done this like this? Let's call it what I'm going to do is, instead of printing them like this, I'm going to do this. Oh, no, not print 2. Sorry, I initially thought I would make a new one, but oh, it worked. All right. So I can still do this, right? So it still works, right? But this example was what it was intending to show, is that if I were to send this object array into here, and if I were to do some type of comparison amongst the elements of this list, I could end up comparing the two together. So let's say like this. Let's do it like this. This might not work actually. Color error. Nope, it does. Okay. I didn't think that would work. Let's see here. Yeah. So you see it still works there. Okay. But let's say I wanted to print them in a sorted order. Let's take this and I want to just say, okay, first java.util, I think it is. Okay. So let's do this first. Let's go ahead and do a debug stop. All right. So here 1, 3, 2, 4, 5. So we're going to step in to this And the very first thing is we're going to sort the list, right? 1, 3, 2, 4, 5. So now it's 1, 2, 3, 4, 5. Good, right? That's what we'd expect. So 1, 2, 3, 4, 5. Now we have a list of some different cities here. First, we're going to sort them, right? So we sorted them by alphabetical. Okay. Now we have a print both, right? And now, what's going to happen now? What's going to happen when I click on this? What's going to happen? Okay. An error, right? So Furcon says a runtime error. Rejip says a compiler error. Everybody else just some type of error, but I'm not sure which. Rejep, are you saying you're mistaken about the error or the specific type of error? Okay. Yeah, I think you're right. So let's take a look. Oh, show. Wow. Okay, so an exception. The reason why you should have been, you guys should have been able to say if an error was going to occur at this point, it was going to be a runtime error because I had already compiled the code and started running it. If the code is in the process of running already, then you cannot have a compiler error at that point. But basically the idea is here we cannot compare an integer to a string. Can't do it. Cannot do it. All right. So if we go back, we say so I'm compiling it and it runs and it's fine. Okay. Now if I try to do this and I try to compile this, right, that should not have worked. Oh, it's doing those actually. It's automatically doing that. It's still going to give me a runtime error, isn't it? Yep, there it is. So, but I think the point this example is trying to tell us is that if you find yourself in a situation where you are seeding the generic thing, where you're saying it's an object, then there's probably some problem. There's probably something you're not doing quite correctly. Because if it's expecting a certain type, if it's expecting you to tell me what type of value, what type of array, what type of whatever are you giving me, then there may be something it's trying to do inside of the method that requires all of these to be of at least the same parent type, right? Or at least the same class type. Okay. All right, let's turn this back. Actually, I'll leave this like it is. I'll leave this like it is. Okay. A couple of other examples. Let's see, what was the other one that you wanted to ask about? That was the other example. Not generic method. Okay. Where's my demo? It's the comparable thing, but why is it? Okay, let me get that. Okay. This was another one that we had looked at in the slides here. I'm not finding the example that uses these two max methods, so I'm kind of confused where those went. Okay. All right. So here we have where we're going to pass two geometric objects. All right. E, it can be anything, but it must extend geometric object. So I could pass it a rectangle and a circle. I could pass it a circle and a circle. I could pass it a rectangle and a rectangle. Pass it anything. Okay. Anything that, as long as both of these extend whatever geometric object is. Right. So this rectangle, this circle do not have the same area. I pass it the same circle twice. Right. Same area is true. If I pass it the same rectangle twice, then it's also going to be true. If I pass it a circle, then a rectangle, circle with radius 2, same area is false. If I pass it a rectangle with, that is a 4 by, right? Then that should be true, right? Yep. Right. Okay. So, and what I've done is I've said for this method, right, this equal area method, I want to tell what E type am I allowed to pass it. Okay. Now, what if I did like this? What if I said, I want to pass it the same two things twice? What do you think will happen here? Yeah, let's see. Yep, compiler error, right? Nope, I can't do it. So let's see, what if we did? What about this? Will this fix the problem? No. What about this? Will this do it? Where was my generic method? Let's see. I'm trying to understand what's the difference between this and this. What's the difference between this and this? Oh, what do I need to do like this? I need to do bounded type demo. Oh. Hmm. This did E, this did E. Now I'm confused as to why this isn't working like I think it should. Well, we know that this works, right? Do this. We know that one, right? No. But here's what I'm confused about. Why does this, without taking the extends out, because I'm saying pass a geometric object circle, pass a geometric object rectangle. Into this, I'm saying it has to be an E, right? It has to be a geometric object. It has to be this. Why does that not work the same as this? Yeah, they both extend geometric objects. So why does this not work? Why does it work here and it does not work here? Yeah, but are they? They're members of geometric object, right? Okay. All right, so I'm going to answer this question because I'm sure some of you are like, I don't know, that just seems so weird. All right, and then we'll call it a day. Okay, so here's what's going on. All right. Basically, okay, here's the big problem. This method, when we compile this method can exist anywhere. It could be called from outside. Excuse me. It could be called from outside of the bounded type demo. I could call it from another program. Okay. Which means I could make E be something else if I called it from another program. I could make it a string. I could make it an integer. I could make it a student object from like your assignment. I can make it anything. Okay. Does student, does string, does integer, does that have a get area method inside of it? Does your student class from the assignment 2, does it have a get area method inside of it? I hope you all said no, it does not have a get area method. Hopefully no students have an area, okay? Which means that it does not understand what the get area method is for this. But when we say this, when we say extends geometric object, what we're saying is if anyone were to call this method with some type, it must be something that extends a geometric object. They could create a circle, they could create a triangle, they can create a sphere, they can create anything as long as it extends a geometric object. It can create their own new class that extends geometric object, and then they could use that class to pass it to here. Okay. So then you might be asking me, as I would ask if I were in your shoes, if I were in your position. Let me go ahead and put these all back to the way they were. So now it should compile fine and run just fine and everybody's happy. Okay, so then the question I would be asking if I were you, then why did it work here? Then why did this not give us a compiler error? Can I not call this method outside of the class? You absolutely can. You could call generic method demo with some other E here. Right? You could create some other E on this, right? So then why did this work? What if I called it with a string? What if I called it with a student? What if I called it with a department? You know, whatever. What inside of here, what inside of this method does not exist for the object class? Nothing. All right. If I pass an array of objects, I can sort the array, no problem. That for whatever the object type is. I could find the length of the array, that's fine. What does this do? What method would this call? When I look at the item at index I, and I go to print it, what does it do with that object? What method does it call? What do you think? I said what method inside of the integer class does this call? Right, the toString method. Exactly. This is the same thing as if I had written that. Those work the exact same way. Okay. So we call the toString method. And does the toString method exist in the object class? Yep, absolutely. And so because nothing inside of this method, yeah, nothing inside of this method does not exist in the object class. This is the same as if we had said extends object, and it's okay. And all E's out there extend object. So what we could do is we could say, okay, let's do this. Let's take a look. Let's see if this will fix our problem. Don't do this, by the way. This is bad. No compiler problems. Because what did we do? We took away the things that were specific to a particular class, geometric object. But when we add this extends geometric object, we're saying I want this to be something that is inside of the geometric object class. So everything inside of this method, if there's an object of type E and E extends geometric object, then I can only use stuff that exists in geometric object or one of its parents. And here, what I said was E basically said E extends object. Inside of this, if there is an E type thing, so here, this is an E object. It must only use methods and properties that exist inside of the object class. Well, toString does. And because toString does, I can use it. Okay? All right. So that's a bit about how generics work. I didn't go into great detail with them today, with generics today for you. But it is an interesting read for anybody who's interested in understanding more about them. One thing we didn't do a lot of today is I didn't talk a lot about other parts of generics such as wildcards and all of that. But all of that's available here for you. Let me go ahead and this one's right. Want to make sure I run it back to the norm to correct. Okay, good. All right, so I didn't do a lot about the wildcard, and there's some wildcard demos and stuff like that. Look into that if it's something that that you might find interesting. You know, this isn't a super important thing, but I will say the first hour of what we talked about, the activity diagrams, very, very important that you understand that and that you're able to show your understanding of that on assignment 3. Okay. All right, guys, we will call it a day there. And for any of you who still have exams to complete, I wish you well on those and that you'll have lots of success. All right. Have a good afternoon, and I'll see you in 1 week.